Apache Flink. It's a scalable, fault-tolerant, and above all, trustworthy way to do stream processing. And it's the de facto standard way to do real-time processing of any kind. I'd like to show you the basic architecture of Flink and give you an idea of the kinds of APIs you have to choose from when you're using it. We'll talk about what Flink does, what it doesn't do, how to deploy it, and where to go for further study. Now let me give you the most general architecture diagram of any Flink job possible. So we're going to start on the outside with a source of data. That source is going to come in, and then we're going to have our job or job graph or topology or whatever we want to call that. And then that's going to go outside of Flink by way of a sink. Data out there comes in, we do stuff to it, and then we put it somewhere else so people can see it. So that's really the idea. Now, what's a source? What's a sink? What's that all about? Well, often, Flink is a stream processing framework. Often that's a Kafka topic, okay? Very often. So that's probably data from Kafka coming in as a source, and probably the sink is going back out to Kafka, but it doesn't have to be Kafka. The data could go out to a relational database. The input data doesn't even have to be what we think of as a streaming source. It could be maybe some files. Maybe we've made some bad life choices. We ended up with some CSV to process. It happens. We should give ourselves some grace. That sort of data, that could also be a source that we pull in and do our computation on in Flink. There's lots of options for source and sink. And Flink really sees streaming and batch the same way. Batch is really like streaming data. We just know the start and the end. It doesn't go on in an unbounded way. We know where it starts and where it stops. So a lot of this code in our job is going to end up being exactly the same, regardless of where that data comes from. All right, let's take a look inside this middle node at the actual computation Flink is doing with something a little bit more realistic. So we're going to imagine that we've got a Kafka topic and it's got two partitions. And this Kafka topic has shape data in it, just to make this easy to look at. So we're going to have these two source nodes, and they're going to be doing the work of consuming from that Kafka topic. And let's take a look at what kind of data is in them. So these are already partitioned such that we've got squares on the top and circles on the bottom. Here is our data that we have sourced. And what we want to do is we want to count all of the colors, the unique colors, but we don't like orange. We want to filter out the orange. Now to make that happen, we are going to have to shuffle. So we'll keep green down on the bottom here. So that's going to go to this node. But we've also got these two blues. We're going to send those blues to the top. We want them to be up there. However, on the top, draw this arrow, we've got a couple of greens. Those are going to go to the bottom, yes. And then we have a blue square. And we'll just X that out there. This shuffle is putting all the common colors on these two nodes, which can then generate counts and send them out to some kind of sink. So what do we have here? Looks like green is a 3, and hey, what do you know? Looks like blue is a 3 as well. Of course, these counts can change in an ongoing way as we're ingesting more real-time data through this pipeline. We're always going to see on this sink the current value of the count that's moved through our pipeline. And by the way, these nodes here are the ones doing the filtering. You'll see after those, there are no more orange shapes. So that's, a somewhat more realistic thing than just a single node there. You might see something like this with these sinks and these sources and sinks and operators. Where do these run? Now, Flink is a distributed system, and this is going to run on an actual server somewhere. We're going to have a process called the task manager, and it will have some number inside it of task slots to which we can allocate tasks, and those tasks are going to run these actual operators that we've got from down here. Now, I don't have any visual way of distinguishing between these different operators. I've just drawn them all as green circles, but each one of these is going to be mapped into a task slot. Sometimes they'll be grouped together in a way that optimizes them if they should be running in the same task, but that's how this works. Because Flink is a distributed system, of course, I might have lots of task managers. I might want to scale that out if I've got a really big job, lots of partitions, multiple jobs running. I might want there to be lots and lots of tasks to be able to do all that work. The stream processing topology gets decomposed and the tasks get scheduled by the job manager. That's going to take this job expressed using the API, which we'll cover in just a minute, and then scheduled off into slots in the task managers. Should a task fail, I mean, it happens to everybody, the job manager is also responsible for rescheduling them. That's a part of the fault tolerance story that Flink has. Now, how about APIs? What are our options there? There are a few. The data stream API, the table API, and happily, good old-fashioned SQL. Those are all options that we've got for expressing this kind of topology. The data stream and the table API are available in both Java and Python flavors, which for this kind of work is very inclusive. And of course, SQL is just SQL. There are a few extensions to SQL, as there always are in any particular implementation, to handle some of the unique situations that have to do with stream processing and sources and sinks and so forth, but it really is just SQL. But which one should you choose? Now, if you want to use SQL, you probably know who you are. If you're using something Java or Python, you have a choice here. Which way do you go? Now, the data stream API, very powerful, plenty of people using it, but steep learning curve. It is known to be very challenging to get started with. Also, it tends to be expensive to operate. It's interesting how some architectural changes down here at the API and infrastructure level end up having implications for how this stuff's going to run. So if you're going to operate it yourself, particularly if you're looking for a fully managed Flink service, which is an advisable thing, usually data stream jobs are going to cost more to run. And table API jobs, you'll probably be able to find something more cost effective for them and for SQL. So that's basic guidance where to go when picking your API. Well, this is what Flink does. What doesn't it do? There are a couple of important things. Now, you see all of this data storage external to Flink itself. That's because Flink doesn't store data. Now, some of these operators down here in this topology are going to be stateful, and there's a state store. As you grow in your Flink knowledge, you're going to learn lots more about state management inside of operators. But Flink itself is not a database. It's not data storage infrastructure. That's going to be Kafka. That's going to be a database. That's going to be CSV files in the cloud or wherever that is. Also, I've created these counts, and I saw we put them in the sync node. They're going external into maybe a database where I could query them. If I wanted to be able to look up by shape what my current count was, that would have to go somewhere where I could do that query. Despite the presence of SQL, Flink is not a database, and you're not able to query it directly. So that's what syncs are for. Of course, this is all just the beginning, and you're going to need to learn more. To do that, you want to go to developer.confluent.io. There are several full-length courses on Flink covering different aspects, different APIs, different concerns. There's a lot to learn. And if you want to try Flink out, probably the best place to do that is Confluent Cloud. There's a link in the description and a code that'll let you get started for free, ingesting data from Kafka, doing computation on it, putting it back into Kafka topics, and being able to see everything you do. Highly encourage you to check that out now and leave us a comment. Let us know what you're building. You know, I always love to hear those stories. Thanks.